And then, of course, if you have one or the other solution, in this case here, a solution using this volumetric prefabricated elements, which you just can bring in sideways. You can stack them one on top of the other. So this is the example of a school in Frankfurt, which was fully built from these modules, in just stacking them, and up to 4-story buildings of quite large dimensions. Costing and so on, of course, in the end you will find out if that was cost efficient or not, but some people think that for certain applications this could be a very good way to do. Now let's have a look at some more standard solutions. This is the World Tennis Tour for women. We had a tour stop in Biel, just next to our school. They built this tennis hall. So this is a sports hall, if you like. So the requirements for insulation, building physics are not as big as if you have Minergy or passive housing and so on. So it's straightforward. This is a straightforward structure, and it has been selected as a solution because it was cheaper than any other solution in steel or in concrete. So that was the reason for building it. But what you need here again is you need someone who is able to produce, for instance, these large glulam beams. They would span probably something like 28 to 30 meters, curved and tapered, but this technology is actually available since ages already. This is nothing special. All our companies in Switzerland, they are able to produce such things, bring them on site, have it quality controlled, and actually prefabricated in a way that it is easily erected. All the other stuff like posts or bracing, this is carpenter skill, and there's not much engineering involved in that. In terms of facades, easiest and cheapest way is to take some profiled aluminum facade with a minimum insulation that is required to keep running this displays. So from the outside, you don't see any timber at all. It's just a warehouse, or it's a building with no kind of identity. And I think that Roger Federer wouldn't really care if he's playing in a timber place or not. But it was a good solution in this case, and an economic solution. This is another very interesting project showing again how prefabrication is important. This is actually the arrival of this cable car is here. They had to refurbish this place and wanted also to provide a restaurant on top of the mountain at an altitude of maybe 2,400 meters. So it's a skiing area. For a long period of time, there is heaps of snow up there, and people would go on the runs. Now, this is a very nice project that has been developed by Herzog & de Meuron, so the architects amongst you should probably know them. And here the idea was, how do I possibly get all my timber structure up there? It's a big building, or quite a big building actually. So what you can see here on top is all the thoughts about how you organize your structure, make it to small prefabricated modules, which you can then bring up on this site. And everything was actually brought up with a cable car. They wouldn't fly elements up. Everything was just sized to the capability of that cable car to bring it up. Of course, what they had on site, as you can see here, there was a crane. This crane, maybe they flew it up for having larger sections, but and then they would install all this building on top. So this is not a complicated structure what you have here, and you can cope with the high snow loads. This is not too much of a problem. The problem here was more like the organization and the process of manufacturing, bringing it up to there in the right time, and having also the solutions for all the connections ready to have a neat final solution. So most probably this fancy kind of platform in concrete took them heaps of time to build up there. Maybe during one season they built that one, and this building here was just during a summer season. In a few weeks it was just finalized. Everything prefabricated, everything quality controlled. It fits together. There's no mucking around with chainsaws and the circular saws and whatever, and you build it. If you look at the rafters here, they're kind of biggish. That's all right because there is a big load, but you can see or feel a little bit how precise this solution is. If you look at the rafter ends, they're exactly inclined the same way, and they're at plus minus 1 millimeter positioned. So very nice kind of solution. Well, this Of course, there are many other issues on this structure as well. Here is an inside view. You can imagine that in wintertime, all the people will drag snow in there. It will getting moist, and you have to kind of take away the melting snow. So there were big developments already on the floor, so that it can work with these environments, that you can collect the water somewhere, that it can evaporate again. So in terms of building physics, there's quite a lot of things to be thought around here. Additionally, this place is not, nobody lives in this place during nighttime, so fire issues, fire concepts are also very important to make this place safe, and to have everything in place in order to act if something happens. So very nice example with some specific or special processes behind which were actually the key issues on that building.